Hey, we're continuing with the 2008 multiple choice portion of the AP AB calculus exam. So number 10, the graph of the function is shown for t between 0 and 3 of the following, which has the least value. And the definite integral of f of x from 1 to 3 will give us the exact value under the curve. And then we have to compare between left Riemann sum, right Riemann sum, midpoint, and trapezoidal sum. So I have a diagram of each of those. And we can say left Riemann sum, where each rectangle that we draw has the left upper corner attaching to the graph. So we see that these rectangles are gonna sit above the curve. So this is gonna be an over approximation. A right Riemann sum we see is going to be an under approximation because a decreasing curve with the right endpoint connected to the graph will always produce an under approximation. And part E, we're also going to get an under approximation with the trapezoid, but it's more accurate. As you can see, there's less gaps. And for D, we're not exactly sure. We just know that this is going to be somewhere. Maybe it's an over approximation, maybe it's an under approximation. We're not going to be able to make that determination. However, we can tell that the least value would have to be the right Riemann sum. Hey, number 11. The graph of function f is shown above. Which of the following could be the graph of f prime, the derivative of f? So we have the original function graph, and if we want to find the derivative graph, we can create our sign line. So our sign line would, slope sign line would indicate where the slope is 0. So slope is 0 at -1 and 1. Well, I used -1 and 1 to, so I can just have a value to mark off. And we see that to the left of this max, we see a positive slope. So that's a positive slope. Between -1 and 1, a negative slope, and then to the right of 1, a positive slope. And if we want to convert this to an f prime graph, we're going to have -1 and 1 being the x-intercepts, because this is where slope is 0. Above the x-axis represents positive slope. Below represents negative slope. So we want the portion to the left of -1 to be sitting above the x-axis. Between -1 and 1, we want it to sit below the x-axis. And then to the right of 1, we want the graph to sit above the x-axis. So it's also making sense that your derivative of an x cubed will produce a quadratic, a 2x squared or a 3x squared. Okay, so then we see that our options would have to be B as the best choice. Okay, number 12. If f of x equals e to the 2 over x, then f prime is equal to. So we have to go through chain rule. The rule for e to the u is e to the u times u prime. And but before we apply chain rule, we have to get this exponent in the form where we can find the derivative easily. So 2 over x, the best way to rewrite that so we can apply power rule is 2x to the -1. Okay, so my rewritten function is e to the 2x to the -1, and the derivative of e to the u is e to the u times u prime. So the derivative of 2x to the -1 is simply -2x to the -2. And if we clean this up to match with one of our answer choices, I'm going to write it as -2e to the x over 2 divided by x squared. Okay, 13. If f of x is equal to x squared plus 2x, then the derivative of f of natural log of x is equal to. So first, let's figure out what f of natural log of x is equal to. So f of natural log is simply replacing every x we see with natural log of x. So here is my f of natural log function. Now, if I want to find the derivative, then I have to apply the appropriate derivative rule for each portion. This portion, I can use chain rule. So bring down the 2, keep the parentheses, multiply by the inner function's derivative, which is 1 over x. And then 2 natural log of x is simply 2 times 1 over x, because the derivative for ln of u is just u prime over u. And then once we're here, then we can try to match it up with one of our answer choices. I can find a common denominator easily. They already share the common denominator, so I can just write this as one fraction, 2 ln of x plus 2 all over x. Okay, number 14. The polynomial function of f has selected values of its second derivative, f double prime, given in the table. Which of the following statements must be true? Whether is it that the function is increasing from 0 to 2? Is the function decreasing? Does the function have a local maximum at x equals 1? Is there a point of inflection? Or is there change or concavity in the interval from 0 to 2? Okay. Now, we know that we see when f double prime is equal to 0, that is a potential point of inflection. And we see that to the left of 0, we see a positive value. To the right of 0, we see a negative value. So the first instinct is to think that, well, this must be a point of inflection because we see a positive on the left and a negative on the right. However, these are just selected ordered pairs for the function. There may be a variety of different things occurring between 0 and 1, and there could be a variety of different things occurring between 1 and 2. So we have to take those into account because we don't have the full picture. We just know that these ordered pairs exist on the graph. And we know that this is a polynomial function, so it's going to be a smooth curve, and it's going to be differentiable and continuous. So because it's f double prime being equal to 0, we only have the second derivative. We don't necessarily know enough information to say anything about increasing, decreasing, or a local maximum. Now, part D and E, these refer to second derivative information, which is point of inflection or concavity. So it looks like it's going to be one of these two choices. Now, I think most students are going to try and gravitate towards part D because it seems like just because we see a 0 and we see a positive and we see a negative, we're going to assume that there's going to be a point of inflection. However, what if the graph looks like this? What if there is, what if between 0 and 1, there's a negative 0.5, and let's say negative 0.5 has a concavity of, or to the, sorry, negative 0.4 has a concavity of a positive value. Then what that means is that there may not be a change in concavity at 0 because maybe to the left of this order pair, we're also going to get a negative a value. But here, actually, this should show a negative value to the right of 1, and so it's possible that we may have two negatives here, and we have a positive there. Okay. Okay, so it's possible that that at 1 there may not be a point of inflection. However, because there's a change in sign somewhere between 0 and 2, we know that there must be a point of inflection. It's possible it's going to be at 1, 0, but it could be elsewhere. So we have to make a more general statement that f changes concavity in the interval from 0 to 2. Okay, number 15. We have the integral of x over x squared minus 4, the indefinite integral. And if we want to find the indefinite integral, the first thing we want to check is, can we apply power rule? Can we simply rely on expanding and splitting up a fraction? But here we have too many terms in the denominator, so we're going to have to look to u substitution. So u substitution, let's let the u value be the denominator and see if that will allow us to cancel out the x's and leave us with an integral that we have a rule for. So u is x squared minus 4. Our derivative is 2x. And so dx is going to be du over 2x. And we make our substitutions. So x squared minus 4 gets replaced with u. The x will stay initially. Dx gets replaced with du over 2x. The x's cancel out. We pull the 1/2 in front. So now we have something that is a clean rule that we can apply, which is the natural log rule. The integral of 1 over u is simply natural log of the absolute value of u. And finally, we replaced our u value with x squared minus 4.